Hi students, how you doing? Today's lesson is solving for unknown angles. Let's get started, okay? We're going to find out some missing angles, looking at different shapes, looking at different situations. Hopefully it'll just be a couple of problems, okay? We'll try to get through this quick. So today's goal, say hi to Karen over there. She's for real today. You'll be able to reason through multiple steps to find unknown angle measures and then recognize when an equation represents a relationship between angle measures, okay? So we're going to start looking at shapes and find what's missing in those angles and also get some equations from it, okay? Let's go ahead and get a warm up. First things first, so a lot of us mathematicians, okay, including myself, including you, I know you definitely want to be a mathematician, refer to a length of a segment by naming its endpoints. So two words there, segments and endpoints, okay? All that is a segment is basically a line, and then we have the two endpoints that go from, maybe you could say from the start to the end of that line, right? If I was to look at for segment AB, I could say that, well, A is right there, B is right there, so there's your segment. That line between from A to B is your segment, okay? So now let's look into an example problem. I want to see if these are true or false. I have here A, B, C, D on that line segment right up there, right? Let's check each equation. Let's check each equation that we got. So here I have CD. I'm going to mark that right here. And I'm adding BC to it. Okay, that's going to be all in red. So I have CD plus BC, these right here. The question is, does that give me BD? Look, BD. Again, with these segments, we're looking at the endpoints, right? We start at B, we end at D. Okay, so is the red equal to the green? Looks like it is. That means they're equal to each other, okay? So I'm going to say that is true. All right, let's try that again. Now I have AB, which is right here, plus BD. So you notice how we're adding those segments, A to B, and then B to D. We're combining those two, and that creates this big giant one of AD, doesn't it? But does that equal CD, this little part, plus this bigger part, AD? If I put AD and CD on top of each other, right, does that give you AB plus BD? Well, notice how AD is already that whole part, but CD is that little chunk right there, right? Well, that little chunk tells us this is going to be false. But if I was to fix this, I saw that AB plus BD actually gives me AD only, not that extra CD part, right? So that one is going to be false. Let's go and look at this next one. Now I have AC minus AB. Let me try using two colors, okay? So AC, you see that's that longer part. AB is that smaller part. I'm going to use this bottom still. If I take that segment AB and cut it off right over here with AC, what looks like is remaining? Well, that looks like it should be BC, right? Again, I'm taking that AB, I'm cutting it off from A to C. I have that remaining BC right over here. But it's asking me, if I do AC minus AB, does that just give me AB instead here? Okay, the answer is false. Okay, instead, I can see that this is false. AC minus AB really gives me BC. Okay, that's what's going on here. All right, let's look at this last one. We'll see if it's true or false, okay? So in red, I have BD. That's his right side over here. I'm subtracting now CD. So I'm taking CD right over here, right? I'm taking that away from BD, the bigger one. So really this cuts it up to, it looks like segment B to C. I need to see now, I need to check if AC minus AB also is going to be B to C, okay? I need to check if this right here is going to give me BC. All right, so let's do that. So I have AC. Let's use rainbow. AC is this top part. Subtracting AB, this other part. So AC is that longer one. I get AB. I cut it off. Cut it off. Do I have BC remaining? And if you say yes, you are correct. If you said no, double check this. We got the long part and we're getting cut off by that small part, right? What's remaining is that B to C. So that is also BC, so therefore this is true. All right. Does that sound good? Feeling good about it? Awesome. Okay, so let's look at some matching pairs. We're going to look at angles now, okay? That was a warm-up. That's just getting us thinking about different shapes and adding and subtracting things on, okay? But we're going to still use the concept of supplementary and complementary. Remember, supplementary is when you have 180 degrees, usually when you have a horizontal line. Complementary is when you have 190 degrees, usually when you have a right angle, right? A 90-degree angle, okay? So we're going to look at all of these different equations and match them. Remember last time we learned vertical angles as well. We're going to apply that too, okay? So here I have A, and I have B right down there. I need to match those two problems with one of those equations, okay? Don't get too intimidated with the equations. We're totally fine still, all right? But let's look at this. So here for A, I'm only given this part over here. I'm given a G and I'm given an H. Remember yesterday's lesson said vertical angles? They're the same, right? Are these vertical angles? Remember, vertical angles are when you have opposites, when you have angles that are opposite from each other, okay? When it goes through an intersection. When you have a line that crosses, the angles that are opposite to each other are equal to each other, okay? So this is saying that G equals H, and that's what we have right there, isn't it? Okay, next part, B. So I'm trying to figure out an equation with this, okay? Again, I have that horizontal line. So because I have this horizontal line, I know that is going to be supplementary. Okay, that's supplementary. With that supplementary, that's equal to 180 degrees, right? So I can say that the angle with G plus the angle of H, that's going to equal that horizontal line, which is 180 degrees, okay? Is there one that matches that? Oh, looks like it's already the second one right there, okay? That makes sense so far? Okay, we got about 3 more, I think. Hopefully you're feeling good about this. Next one is, now we're getting a little bit harder, right? So I need to figure out which of those equations over there will match this scenario, okay? So don't stress too much because, again, here I have crossing lines. Do you notice anything about G? So if G is right there, I could say that the angle across is also G because vertical angles, okay? So those are vertical angles. We call those vertical angles. In this case, it's literally vertical, right? So now if I was to look at that, I have here again that horizontal line. I'm trying to get an equation out of it. That horizontal line represents supplementary, which is 180 degrees, right? And so I can say that to get 180 degrees, I know if I add all those angles up, that's going to give me that 180 degrees and horizontal line, okay? So really what this is going to be 35 plus angle G plus angle H, and that's going to give me that horizontal line, which is 180 degrees, okay? That looks like it's the third one here, all right? I think I didn't mix them up. I'm just saying, but hopefully this is making sense. Okay, a little harder, right? Same situation here. I got G right over here. There's those two crossing intersections. So I know that the opposite of where G is also going to be G. In this case, you should see by now we create something like this, which is 90 degrees. So what do I have in those 90 degrees? What do we call that? Remember that was complementary. That's with 90 degrees. And so I know that whole part is 90 degrees. So now everything else inside combined together, I should get H plus G plus H equals 90 degrees. Or if you know what we've been doing with like terms, combine what's the same, right? I have two H's, so I can say I have 2H plus G equals 90 degrees, okay? That one is right over there. I might have not switched it up. That's okay though. Okay, this last one. So I already gave you that horizontal line. Perfect, right? We call that what? Supplementary. That's when the whole thing, that horizontal line, is equal to 180 degrees. And I have all these other ones inside, right? If I was to make an equation for it, I could say, well, it's 48 plus whatever g is plus h will give me 180 degrees, okay? So there's your equation for that. And that looks like it's going to be this last one. All right? So hopefully you're feeling good about that. That's pretty much what our lesson is for today, okay? Pretty simple, right? Again, if you know that the angles A and B are vertical, so you know they're opposite to each other, then you could say that they're both equal to each other, okay? So what I'm saying is if I have A right here and B, they're opposite to each other, they're equal to each other, okay? Man, this is like burning my eyes. I don't know about you. The next one is if I see that I have that complementary angle, that 90 degrees, I know that two angles added together, C and D, would give me that 90 degrees, okay? So again, let me do this in black. If I have something like this, and I get split up by whatever thing, this is 90 degrees, that could be C, and that could be D, okay? Those two added together is 90 degrees, all right? And then same thing with supplementary. If I have something like this, that horizontal line, let's say I have a line through there, I can say E plus F is equal to 180, okay? So that's pretty much the lesson today. Today's goal is that we're able to reason through steps to find kind of the unknown measures. Again, we're adding everything together to get 180, right? Or we can subtract one part if we wanted to. And then we can recognize when an equation represents a relation between the measure angles, okay? So please keep in mind, there is a cool down with a learning activity. There's only 4 questions, I believe. Again, if you need help, come to my office hours, send me a quick email. I'll try my best to reply to you, okay? Other than that, make it a great day. We'll see you mañana.